Hello there. So now that you have an understanding of the mean and the weighted mean, which are the most commonly used measures of central tendency, we're going to shift our focus to the median and the mode. So when we talk about measures of central tendency, we're really just talking about the mean, the median, and the mode. And all three are just numeric ways to describe trends in data simply without looking at a ton of numbers on a spreadsheet or on a screen or on a piece of paper. Now, in the next lecture, we're going to talk about which types of situations lend themselves most appropriately to the mean, the median, or the mode. But before we get there, I want to make sure you understand all three measures of central tendency in their own right. So in this lecture, we're going to focus quite a bit on the median because the mode is more straightforward, but the median is going to be looking at the notation and the formulas associated with locating the median. Also, we're going to do some examples with raw data for either odd or even number of scores, and you'll see why those two different scenarios lead to different ways to find the median. And then I'm also going to show you how to figure out the median in a frequency distribution table, which is a little bit more complicated than when you're working with raw data. Then we'll end on the mode, so just how to identify it in raw data, how to identify it in a frequency distribution table, and how to identify it in a frequency distribution graph. So unlike the median, where it's a little more complicated if you have data in a frequency distribution table, the mode, it's a lot easier to identify if you have it in a frequency distribution table or in a graph. So now let's focus on the concepts and the notation and formulas for the median before I move on to some examples. So the median, put simply, is the midpoint. So the median separates the 50% of the scores on the low end from the 50% of scores on the high end. Now we'll get into the odd versus even number of scores situation, but sometimes when you have an odd number of scores, there's a single score in the middle. But if you have an even number of scores, there's going to be two scores in the middle, and you just find the mean of those two scores. What the bulk of these formulas that I'm going to show you in a little bit are focused on is locating the position of the median, not necessarily calculations. So again, the median is the midpoint. And you'll see here that there's two different ways to notate the median. So if you're working with a population with all of the scores that you're interested in from the population, then your median is going to look like this, like a little U with a funky, I think that's called an omlaut above it. If you're working with a sample, then the notation is an M with a subscript D. Sometimes, and you usually see it this way, it just says median equals. All right, so the median index is all about locating the position of the median. So this equals, the median index is all about the location, not value. So be really careful with that. You'll see why in a minute. So if you have your median index, which you just take your sample size, the total number of scores, divided by 2. Because remember, we want to split that in half because we're looking at the midpoint. So we take the total number of scores divided by 2, split it in half. If you end up with an I value that's not an integer or not a whole number, you're going to get something 0.5. That means that you have an odd number of scores. Because think about it, if you have an even number of scores, you divide it by 2, you're going to get a whole number. So think about it, 12 divided by 2 is 6, 14 divided by 2 is 7, 15 divided by 2 is 7.5, right? Because it's an odd number. So again, if you take n divided by 2 and you get an integer, that means you have an odd number of scores. So you could also think about the other way, right? You're like, I have an odd number of scores, so I know that when I take n divided by 2, I'm going to get something that's something 0.5. But then again, with the odd number scores, there's just that one midpoint. And to figure that out, you round that value up. So for instance, if you had 15 scores, and you divided 15 by 2 and you got 7.5, you'd round that 7.5 up to 8, and the 8th score is your median. See how that works? And I'll show you examples as well. Now, if you have an even number of scores, you're going to have two scores that are located in the middle. And so when you divide n divided by 2, you're going to get a whole number. So for instance, if you have 14 scores, 14 divided by 2 is 7. But you want to go with the 7th score, so that would be the ith score, right? Whatever n divided by 2 gives you, and then the score just above it. So ith plus 1 would be 7 plus 1 in this case, and that would be the 8th score. So you'd have the 7th plus the 8th score, not 7 plus 8, but the score that's the 7th from the bottom and the 8th from the bottom or from the top. It doesn't matter where you count, but the score is located at the 7th and 8th position in numeric order divided by 2. and that gives you your median. So now let's take a look at an example when you're using raw data and you have an odd number of scores. Now, the first thing that I want to point out is in order to figure out what score is at the position located by the median index, your scores must be in numeric order. So you'll see here that these scores are in fact in numeric order, but if they were not, you would need to place them in numeric order before you could figure out where the median, what score the median is. So if we look at this, what is the median for transaction times? So we need to use that median index. So that's going to be, in this case, we have 15 scores, right? We have 1, 2, 3, 4, yeah, 15 scores. Okay, if you count all these numbers here, you're going to get 15. So we know that this is an odd number of scores. We know that because it's up here as well. And we're going to have one midpoint. So just one score in the middle. So if we take that 15 and we divide it by 2 to figure out the location of the median, right, the median index, you get 7.5. Now remember, in the formula on the previous slide, if you get something that is not an integer because you have an odd number of scores, you round it up. So this 7.5 says we're looking for the 8th score. So let's figure out why the median is this 104. So if we look at this, we can start either from the low end or from the high end because we're going to end up on the same midpoint. Let's just go ahead and demonstrate this from the low end. Again, scores in numeric order. We're looking for the 8th score. So the first score from the low end is at 66, second, third, fourth, fifth, sixth, seventh, eighth. Hooray! 104. If we start from the high end, same thing's going to happen. 1, 2, 3, 4, 5, 6, 7. Hooray! Our 8th score is still 104. Now think about the concept of the median, right? The median's the midpoint. It separates the bottom half from the top half. And in this case, it's pretty clear that's exactly what we did here for the median. So now we're working with a situation where we have an even number of scores. So let's say that Maria quit and her mean time was 99. So between this data set and the one you just saw, the 99 is missing. So now instead of having 15 scores, we have 14 scores. So that's an even number. So again, our values are in numeric order. That has to happen first before you can even think about the median, the location of the median or the median index. So now let's figure out what is the median for mean transaction times. So again, we have 14 scores. If you counted all those numbers, you'd get 14. And that's an even number. So we are going to have 2 midpoints here. So we use our median index and we take that 14, the sample size, we divide it by 2 and we land on 7. Remember, from the formula, when you have an even number of scores, you're going to get an integer or a whole number. So you take the score at the ith position, 7, and then the score at the ith plus 1 position, which is just 7 plus 1, and that's where that 8 comes from. So let's first identify the 7th and 8th score, and then I'll show you how to find the mean of those. So remember, we could start from the low end or the high end. Just make sure your scores are in numeric order. So the first, second, third, fourth, fifth, sixth, seventh, eighth, bam, 104 and 107. Now if we do it from the opposite direction, from the high end, first, second, third, fourth, fifth, sixth, seventh, and eighth, you still land on those 2 midpoints. And yet again, those 2 scores separate the top half from the bottom half. It's our midpoint. So now let's take a look at what we do with those scores. So we find the mean of those scores, right? So we take the 7th score, not 7 plus 8, but the 7th score plus the 8th score, which in this case is going to be our 104 and our 107, right? These scores that we identified right here. We add those together, they get 211. We take the mean or the average of those by dividing by the fact that we have 2 scores that we're working with, and this is our new median. Notice I'm using the population because we're looking at all of her transaction, or all of the mean transaction times of all the tellers at Chase Bank. So now let's focus our attention on a situation where we're trying to identify the median with a frequency distribution table. So we no longer have that raw data written out where we can count inward to figure out what scores at the median index or the location of the median. So if we look at this, the first thing that we have to figure out is the median index. And I'll just write that formula here. Remember, I equals n divided by 2. Well, I know I'm going to have 2 in my denominator, but what the heck is n? Well, remember back when we talked about the weighted mean when we were looking at frequency distribution tables and when we looked at frequency distribution tables for the first time, the way that you figure out the sample size is you add up the frequencies. So in this situation, we are looking at the number of no-shows and then how many times or how many flights had that number of no-shows. So in this example, our X value is the number of no-shows, and then our frequency is the number of flights. So our sample size, our N, is going to represent the total number of flights in our data set. So to figure that out, we need to take the sum of the frequencies. That equals our sample size. And if we add 37 plus 31 plus 20 plus 16 plus 12 plus 4, you end up with 120. So we have a situation where we have an even number of scores. So even n. So that means we're going to have 2 midpoints that we have to find the mean for. So we know that once we find those scores, we're going to be doing some division by 2 to figure it out. All right, here we go. N is 120. And 120 divided by 2 is 60. Okay? So we know we're looking at the 60th score, not 60, but the 60th score. And then remember, we're going to take the score at the position above it as well, the ith plus 1, right? So 60th and the 61st scores divided by 2 because we're looking at 2 scores and we want to figure out the average or the mean of those two. Now this is where it gets a little challenging because you can't really count raw data, but you can count your frequencies until you end up on something that is less than or greater than or equal to 60 and 61. And let me show you how that works. Now remember, you can start from the low end or you can start from the high end. It doesn't matter. Whenever I'm using this technique, I usually start from the end that has the highest frequency to begin with, so I don't have to do as much counting. So if we look at this, we know that the first 37 scores are zeros. Then we know, moving on, that, okay, so the 38th, because there's 31 scores that are 1, the 38th to the, what would that be, the 68th or 69th score is a 1. So that's going to be our 60th and our 61st score. Let's start from the low end. So if we look at this, we know that the first 4 scores are a 5, right? Then we know that 12 plus 4 equals 16. So the 5th through the 16th score are going to be a 4. And then we take that 16 plus 16, okay? So now we've got like the 17th through the 32nd score is a 3. We take that 32 plus this 20, and we know that the 33rd through the 52nd score is going to be a 2. And then we know the 52nd score, or the 53rd score, because we're adding it to 31, through the 83rd score are going to be a 1. So if we look at this, we can see that we're looking for the 60th and 61st scores, right? So to try to keep it simple as you're adding your frequencies, you just wait till you get to a sum of frequencies that is equal to or greater than the indexes you're looking for. And again, the 53rd through the 83rd score is going to be a 1, and that includes the 60th and the 61st scores. So both of our midpoints are 1s. And 1 plus 1 divided by 2 is 2 divided by 2 is still 1. That is our median. So again, you just cumulatively add up the frequencies until you land on a frequency that's equal to or greater than the index that you figured out. And then that tells you where your midpoint, if you had an odd number of scores, or your midpoints, if you have an even number of scores, what they are. So now that our brain hurts a little bit from trying to figure out the median and frequency distribution table, let's shift our focus to the mode, which is pretty straightforward. It's just the most commonly occurring score, the most frequent score. The mistake that students make most often with this is they try to say that the frequency of that mode is the mode itself, but it's not. The frequency just tells you how many times it occurs, and if it occurs the most, then the score associated with that frequency is your mode. Hope that makes sense. And I'll give you some examples too. So again, it's the most common or frequent score. Now keep in mind that you can have multiple modes. So if you have more than one score that's most common in your data set, or if you have a situation where you have two scores, they don't occur the same exact amount of times, but they both occur quite a bit more than the rest of the scores in the distribution, then you can have two modes or three modes, however many modes there are. Also keep in mind, you can have a situation where there's no mode. If you've got, like if you're looking at sales figures or age or something where there's tons of different options, you really may not end up with any single value that occurs more than once. Or you may have all the scores occur 5 times, right? Or maybe you have a frequency distribution where all the scores are the same, so the mode is just the only score available. So just keep that in mind. Sometimes there can be no mode at all. Now, this is easier to identify in frequency distribution tables and graphs, because if you're working with the table, you can just look for the highest F, and then you can go over to whatever that X value is. If you're looking in a graph, you just look for the tallest bar, and that'll tell you, if you go down to the score associated with the tallest bar, you'll figure out the mode. So it's really the best measure of central tendency if you are only interested in what happens the most often. So if you're interested in like your target demographic, like who is buying my product the most, then the mode is the best option. Now traditionally, researchers and statisticians try to use the median or the mean if they can, then they'll settle for the median, and then if they have to, they'll settle for the mode, and we'll get into that in the next lecture. But sometimes the specific question that's being asked lends itself better to one measure of central tendency over another. So now let's take a look at an example of figuring out the mode using raw data. So here are those mean transaction times among tellers at Chase Bank again, and they're in numeric order just like they were when we figured out the median. Now if we look at these values, we can see that every single value occurs one time. There's no value that occurs multiple times, so there's no mode in this sample data. Now let's say that we look at the mean transaction time among tellers at Chase Bank on East Lake Mead Parkway instead of on Green Valley Parkway. And there again in numeric order just to make things simple, and just take a look at that data. Do you see any values that occur more than the others? Well, I see that these two values are 69. We've got 187, 188, 193, 198. Oh, 299s. 1105, 1110, 1120, 1121, 130, 1140, and 172. So just like with the median, putting your values in numeric order also helps you identify the mode if you're looking at raw data because those values are next to each other. So in this case, we actually have two modes. The mode for mean transaction times for Chase Bank at East Lake Mead Parkway is 69 and 99. Now, if we had a situation where this wasn't there, then the mode would just be 99. But in this case, both 69 and 99 occur more than the rest and occur the same number of times, so we have two modes. So now let's take a look at an example where we're figuring out the mode using a frequency distribution table or graph. Now you can see why this is much simpler than looking at raw data because you go straight to the frequencies column and you go, okay, well, this is the largest value for frequencies, and that is associated with 0. So the mode equals 0. If you put this into a graph, it's even easier. You just look for the tallest bar. Bam, there's the tallest bar. The mode is still 0. Now, in this case, I wouldn't say that the 1 is also a mode, although it also occurs more frequently than the rest. But this 31 isn't really that far off from this 30. It's like these values aren't that much different from some of the other values that occur several times. So in this case, I would say that the mode is just 0. So now let's look at a slightly different data set examining the number of flights associated with each number of no-shows. So again, we start by, if we're looking at the table, looking at the frequency column. So we'll go right here. Oh, that 40 is definitely the highest. But if we look relative to the other numbers in the data set, this 37 is really close to the 40, and these two values are way above and beyond the other frequencies. Now, this doesn't mean that our mode is 40 and 37. We have to then think about the score associated with that frequency, 0 and 3. Now, this is even easier to figure out and visualize when you have a frequency distribution graph. So you can see in this graph, this bar right here and this bar right here are nearly the same height, and they're far higher, or representing far greater frequencies than all the other values in the data set. So we go down to the value associated with those tallest bars, and again, we find that our mode equals 0 and 3. Now for the mode, you don't do any math. You don't figure out the mean of those two values and say that it's what would that be, a 1.5 or 2 or something. You just look at it and you say, okay, there's two modes, two most frequently occurring scores.